Hi everyone, hopefully you've seen the video where we convert from moles of one thing to moles of another, which is kind of the most basic part of stoichiometry. Today we want to introduce grams into the equation. So what if we want you to convert from moles to grams, or grams to moles, or even moles to grams? Well, again, this is all stoichiometry, so again we're going to need a balanced chemical equation. If you haven't done so already, I highly recommend pausing the video and writing out balanced chemical equations for the three example problems that you see. That'll be really good practice. Hopefully you've paused the video. Let me bring my equations back up from being hidden. So in our first equation, we are looking at the equation for photosynthesis, We would have some energy over here on the left-hand side needed from the sun to get this reaction going, but that is not going to do anything to our balancing. It's not a quantitative entity. So we have a balanced chemical equation that only includes carbon dioxide, water, glucose, and oxygen. And again, we're going to decipher from our problem what we have and what we're looking for. Well, it says what mass of glucose. So glucose, you know, is this C6H12O6. And it says mass. So mass we measure in grams. So we ultimately are interested in how many grams of this glucose is produced when we have 3.00 moles of water. So 3.00 moles of water, notice we have 3 sig figs involved here, is our starting amount, and we are going from one thing to another. So this is stoichiometry, going from one thing in a balanced chemical equation to something else. Let's start with what we know. We know we have 3 moles of water, 3.00 moles of water actually. Now with 3.00 moles of water, we know one thing before we do anything else in a question, right? So don't be completely stumped, because you know that moles of water must come down here in order to cancel out the units moles of water. Now, we ultimately want to get to grams of glucose, which is C6H12O6. And so the question is, do we know how many grams of glucose are in a mole of water? And the answer to that is absolutely not, right? We definitely don't, because the periodic table doesn't tell us how many grams of one thing are in moles of something else, right? That just kind of doesn't make a whole lot of sense. What we do know, though, is how many grams of glucose are in a mole of glucose. So if we could get some moles of glucose, that might be a helpful stepping stone, right? If I could make this moles of C6H12O6, that would be beneficial. And in fact, we can do that easily, right? Because we know that we have coefficients. We have those pink numbers up there. There's a pink number 6 in front of H2O. There's a pink number 1 in front of glucose. Said another way, there are 6 moles of water contributing to every 1 mole of glucose that we make in this reaction. And once we've done that, again, we're not there yet, because ultimately we want grams. Right now we're in moles of glucose. So we're not there yet, but we know that if we have moles of glucose, we can put it on the bottom so that it cancels out. And we probably remember that we can get grams of glucose from the periodic table, right? Now, glucose is not on the periodic table, but carbon is, and hydrogen is, and oxygen is. So as a reminder, we need to calculate molar masses. Let me do this in red. So we have we have 6 carbons. 6 carbons, they each weigh in at 12.01. So if you multiply that together, you will get 72.06. We have 12 hydrogens. They each weigh in at 1.01 grams per mole, so that's going to be 12.12. And we have 6 oxygens. Each one of those weighs in at 16 grams per mole apiece. That's 96.00. Add it up, and you get, at the end of the day, 180.18, and units are important, grams per mole. So that's the number of grams in 1 mole of glucose. So when we slide back over here, we're going to keep the number with grams, right? Because it was 180.18 grams for every 1 mole. You'll notice now that my moles cancel. I'm now left with grams of glucose, which is what I wanted, right? So this is good news. And if I solve, when you do the math and you put this all together, you'll get 90.1 grams of glucose, which is C6H12O6. If you refresh your memory back to the beginning of the problem, we started with 3.00, also known as 3 sig figs. We are ending with 3 sig figs. So all's well. Let's dive into number 2. In number 2, again, figure out what you know, what you don't know. It says that we're burning magnesium in air, and we are interested in what mass, remember mass is grams, of magnesium oxide. So stop immediately, find magnesium oxide. We're going to put a question mark grams, that's our goal, is produced from 2.00 moles of magnesium. So 2.00 moles of magnesium is what we're starting with. And even though it seems silly to write that out every time underneath, this tells you a couple things. 1, going from one thing to another, you know you're doing stoichiometry. 2, it just kind of helps you keep sense of where you're going in the problem. And it only takes an extra, 5 seconds, right? So it's a worthwhile 5 seconds. Let's start with what we know, which is 2.00 moles of magnesium. You have to start with the known value, right, with a number. So 2.00 moles of magnesium. We are on a journey, and our journey is going to take us all the way over to magnesium oxide, and ultimately we want a mass of magnesium oxide. But if we're not sure where to go, we at least know that moles of magnesium must cancel out. We can't go from moles of magnesium to a mass of magnesium oxide, but we can go from moles of one thing to moles of something else, right? So moles of magnesium to moles of magnesium oxide. Where do those numbers come from? Well, those are the coefficients from your balanced chemical equation, right? So there's a 2 in front of both of these. Even though mathematically this will do nothing, we still want you to write those in so that we know where your work is coming from. We're going to cancel out our units. We're now left with moles of magnesium oxide. Moles of magnesium oxide, of course, needs to go in the bottom. Why? So that it will then cancel out. What are we trying to get to? Well, we're trying to get to grams of magnesium oxide. Right? That's the end goal of the problem. Now, in order to get grams per mole, we would need to use the periodic table. And so I highly recommend you practice this on your own, but in the interest of time, I've done this already. If you add up magnesium and oxygen, you will get 40.31 grams for every 1 mole. Your moles of magnesium oxide will cancel. You're left with grams of magnesium oxide, which is what you wanted, right? So that's good. And when you do the math, you will get 80.6 grams of magnesium oxide. Notice that we are finishing with 3 sig figs because we started with 2.00 that has 3 sig figs. All right, let's try one more. Hopefully you were able to balance up this equation. In this case, notice we're given grams, right? So we're given grams of ammonia, not moles this time. We are given 824 grams of this stuff. We are interested in figuring out how many moles of nitrogen monoxide are formed. So we want moles, nitrogen monoxide. Nitrogen monoxide is over here, NO, and we want a number of moles. So we got to start with what we're given. We're given 824 grams of ammonia, which is NH3. You might not know anything else about the problem, but you know what needs to go in the bottom of the next line, which is grams of ammonia. Why is that? So that it can cancel out. Now, ultimately, we want moles of NO. Do we know how many grams of one thing are in moles of another thing? Absolutely not, right? All we know is the number of grams of one thing in a mole of the same stuff. So that would be NH3. Where does that number come from? Well, that comes from the periodic table. It's the molar mass. So what is our molar mass for ammonia? Again, I encourage you to write it up, or to calculate it. In the interest of time, I've already calculated that it is 17.04. Notice I'm keeping that mass with the unit grams. Keep those together. And that's for every 1 mole of ammonia. This was beneficial because it allows our grams of ammonia to cancel. We have moles of ammonia, and we know that we can relate moles of ammonia to moles of nitrogen monoxide, or NO, simply by using the coefficients from the balanced chemical equation. So there's a 4 in front of NO. You'll notice that there's a 4 in front of ammonia. So again, even though mathematically that doesn't do anything, we still want you to have it so that we can follow your work. And when you do that math, so 824 over 17.04, you will get with 3 sig figs 48.4. And what is that? Well, that's moles of nitrogen monoxide. And now finally in part B, it says in the previous reaction, so we're not going to rewrite that reaction, we already have it, how many moles of water are formed? So we have some options. We could do this, right? We could start out with the 824 moles of ammonia, 824 moles of ammonia, and we could do the exact same thing, right? Except at this stage of the game, we would convert to water instead of NO. But to save ourselves some time, we already have moles of NO, right? And if we have moles of NO, right, we just solved for that. We said it was 48.4. If we have these 48.4 moles of nitrogen monoxide, don't we know a relationship that allows us to equate moles of nitrogen monoxide to moles of water? Right? Because ultimately what we want is moles of water. And we do, right? That is the coefficient. And the coefficients tell us that we have 4 moles of NO for every 6 moles of water. And so if you do that math and you multiply those through, keep your sig figs the same, you start with 3 sig figs, you will get 72.5 moles of water. Final answer, you'll notice that our moles of NO cancel, so we can cancel those out, and we are good to go. And if you're wondering, well, couldn't I take this a step further in all of these cases, and couldn't I add grams to the end? So for instance, if you're looking at this question, couldn't we also convert this moles one more step using the periodic table to grams? Couldn't we go to mass? And the answer is absolutely you could. Stay tuned.